In the east of the Netherlands, a team of 20+ students is working on a very special project, building the best robo-soccer team in the world, divided over 4 technical sub-teams each, with their own specialty within the project. They develop, build and program small-sized soccer robots to compete in robot soccer competitions all over the world. Together, they try to innovate and inspire in the field of robotics and AI. Meet RoboTeam Twente, the robotics and AI student team of the University of Twente.
As a mechanical engineer, I focus on the structure of the robot. Fitting all the components in the robot can be a real puzzle. Therefore, our main work is designing parts in SolidWorks and making prototypes of new features. With our 3D printers, we can go from idea to component in less than a day, which makes the process really efficient and fun.
As an electrical engineer, it's my job to design and assemble all the electrical components of the robot. All features of the robot are divided over multiple in-house designed PCBs, which are made to be as reliable as possible. And after they are designed, it's our job to solder them together.
Control is responsible for making the robot behave as it should, independent on how the environment changes. Optimizing this behavior is done by measuring all the sensor data in real time and plotting them in the software. Control really is the bridge between all the technical sub-teams.
Now that the robots are fully functioning, it is up to the AI team to put them to work. We write the software for our central computer that allows the robots to cooperate and autonomously react to whatever is happening on the field. Using the data from the camera above the field, as well as real-time sensor data from the robots, we make the robots dribble, pass, and of course, score some goals.
Next to all the technical work, we have a management team that oversees all the technical sub-teams and represents the team to the outside world. Together with the public relations team, we are in charge of making sure that the team is known amongst companies and students to attract funding and to find new people for the team. We do this by being active on social media, attending events and working on graphical design, such as the robot covers.
Hello everyone, and welcome to the reveal presentation of RoboTeam Twente. My name is Anne and I'm the team manager of this year's team. Before we start, I would like to take you back almost 10 years ago, when I was in primary school. I had to write an assignment and choose a topic to write about. And I had a previous track record of writing about topics such as dolphins, so I had to find something new. After some deliberation and thinking about what I wanted to write about, I chose to write about a thing called the internet. Back then, and I feel a little bit old saying this now already, but back then it wasn't as prominent in our lives as it is these days, and I didn't use it as much as I use it currently. So, as the good primary school student that I was, I decided to go to the library to get my information. And I got this small little booklet from there with all the information there is to know about the internet. So together with all my research that I did from that booklet and some of my personal opinions, I wrote about what I thought the internet was and what the future of it would hold. Well, my conclusions were actually quite interesting, because I wrote that although very useful and it was fun because you could play some games on it, which I liked, that at least for gathering information, I would always still go to the library. Well, silly me, I don't think I've been to the library in some years, and well, like most of you, I carry a phone with me every day, and I look up all my information online. So then I started wondering, how did someone like me, who did have some interest but didn't really see the full potential of what the internet could hold, eventually go on to study computer science and join a highly technical student team like RoboTeam Twente. Together with a team of 25 people, I started last September to carry on the goal that RoboTeam Twente has of innovating and inspiring in the fields of robotics and artificial intelligence. And we do that in various ways, and the team has brought me to various places this year. And one of those places was in our own building, in the Future Factory, which you've also seen on the video. There I was standing in front of a room of around 20 children. And they were in group 7 and 8, so pretty much the age I was when I wrote about the internet. We were there to give them a masterclass about robotics and artificial intelligence. And when we showed them our soccer robots, I think the first thing they said was, can we play with it ourselves? Which is quite obvious. But after seeing the technology, they were also very interested in learning about that. And of course they were there for a masterclass, so yeah, of course they are interested in it. But we told them about everything there is to know about our robots. We tried to make them understand what we do on a daily basis, and more importantly, why we do it, why we enjoy working on these technologies so much, and why we chose it for ourselves. So that made me think that these children might be in the position where I was all those years ago, where I got impressions on what other people found interesting and made the decision to eventually go on and be here, study computer science. And it made me realize that although not very logical and probably I will never see them again, in 10 years or so they could go on to take the same path as me, to study computer science and maybe even join RoboTeam Twente and stand before you on, in a theater to tell you about the new plans. So today we will not be talking that much about all the inspiration that we try to do, but we will mostly be talking about our innovations, our new soccer robots, what we did in the past 10 or so months. With our soccer robots, we have to be able to compete later this year in Bangkok on a RoboCup, on the World Championships of Robot Soccer. And for this, we had to take an interesting way to be able to innovate them as much as possible, so we're highly competitive and are able to beat the other teams. And our team members will tell you all about that. But throughout their story, I would like you to also look them in the eyes and see if you can see what drives them, why they decided to work in these fields, why they are excited to work in robotics and artificial intelligence, and why they are telling you this story today. So hopefully, at the end of the day, you not only know all the technical features that we may have improved upon, but you also see the excitement in those people and why they have done this for an entire year. So, without further ado, I'm very proud to announce our new plans, and I'm very proud to announce our next generation of soccer robots.
New generation soccer robot, and with this one and 10 others of these, we'll already in a month compete in the World Championship of Robot Soccer in Bangkok, Thailand. And we'll get into the hardware of it later, but first we'll focus on another very important aspect of our soccer play, our software. Because in contrary to what many people believe, we don't actually use these to control our Robot Zero games. We don't have 11 skilled human players standing next to the field trying to pass and score goals. No. We do this using a camera above the field that autonomously controls the robot using our own written software.
Yes, thank you. We are Tim and Alexander, and together with the rest of RoboTeam's software team, we have worked this year on improving our software to make our robots coordinate and cooperate more effectively and execute better strategies on the field. Now we'll go through some of the improvements we've made this year and how they will help us win our matches. So, firstly, we've been working hard. It seems it has crashed. That's not good. Obviously, we do not want this to happen during our matches, which is why we've worked hard this year to stabilize our software. We have changed our code to be more robust, and now it's better able to deal with unexpected situations and edge cases. So whether it's robots suddenly disappearing or appearing or missing data, our code now knows what to do. And this will avoid such pesky crashes ruining our games.
Yes, definitely. But next to stabilizing our software, we also, of course, implemented new features and actually improved features that were already there. Because the start of really cooperative football play is, of course, getting from point A to point B as quickly as possible, in as less time as possible. And, well, if you think about it, if you think of 2 points on a field, there are actually an infinite amount of ways to get from one point to another. But not all these paths have the same time efficiency. And, of course, if you think about it, like, as humans can probably easily see that although RoboTeam likes to take the purple way normally, in this type, the green way is actually probably the better path to take. But how do you explain this to a computer? And maybe even more difficult, how do you explain to a computer how to generate such time-efficient paths? That's why this year we've come up with a new way of path tracking and path planning. It's called bang-bang trajectories. And it makes it possible to guarantee that the paths that we generate are the best possible and time-efficiently fast paths as possible. So they were faster paths. We could get from point A to point B in a very, very short time. But we can already do some of that. You can see our old path planning on the left, and it looks sort of okay. Like, what did we improve on? Well, next to this efficient path planning, we also are able to now predict the future. We can predict where our robots will be in, for example, 1 second from now. And that can really help us to avoid collisions. Because yes, you want to get from point A to point B, but you also don't want to collide in other robots, because if they're your own, you will actually have less robots to play with if they're destroyed, and if the other team's won, then what's a foul? So you don't want to crash. And if you know, for example, that in a second time, your robot will have moved out of the way, out of your path, then you don't have to avoid it anymore. So knowing the future position of the robots can actually greatly improve the efficiency of our paths. And then we generate thousands of paths each second with bang-bang trajectories. And all we have to do is then choose the best one and then execute it and drive to the possible position. But so now we know how to get from point A to point B as quickly as possible. But then the question arises, well, what is actually the best position to go to?
Yes, of course, during our matches, we always want our robots to be in the best position possible. Whether it's one of our defenders blocking an enemy robot from receiving a pass, or one of our attackers trying to find a good offensive position from which it can easily score. It's important that our robots are in the right place at the right time. However, it's not immediately easy to see which position is best for each robot. To do this, we use position scoring. The idea here is that we calculate a score for each possible position so that we can then just simply pick the position with the highest score as our target position. Of course, this leaves the question, how could you score such a position? To do this, we calculate several simple factors for each position, which can then be combined to calculate an overall score for a certain position for a certain robot. For example, if we want to find a good position for one of our attackers to go to, we might look at how open that position is by looking at how far away enemy robots are, and taking a look at how easy it would be to score a goal from that position, and how feasible it is to pass there. By combining these different factors, we can get a realistic estimate of how good that position is. This year, we have worked on improving these calculations. Now, they are vastly more efficient, running well over 10 times faster. This allows us to consider many more different positions when looking for a good place to go to. Furthermore, these calculations have been made more accurate, which means that a score we calculate is now a more realistic measure of how good that position actually is. Combined, this makes sure we're now much more able to place our robots where they need to be on the field. Now, there's a quick example of what this would look like in practice. This might be a little bit hard to interpret, but the black dots you see are enemy robots. It's very hard to see, but on the bottom left there's an orange ball. And the lightness of the image indicates how good we think it is for our robots to go to, in this case for an attacker. So the lighter the image, the higher the score is. So in this case, every point on the field has been given a score, and we can use this to determine where our robots should go. In this case, on the right of the image in the middle is where our opponent's goal would be. And you can see, for example, if you draw a line from their goal to behind one of their robots, it's very dark, which means it's not a very good position for an attacker to go to. And this makes sense. If an attacker goes to a position where there's an enemy robot in front of the goal, it's not a very good place to score a goal from. So using this, we can see, okay, well, somewhere there in the front of the middle or in the left back, if necessary, is a good place for our robots to go to. So using this position scoring, we can really effectively place our robots throughout the field. Now, of course, position scoring by itself is not quite enough. It won't get us scoring any goals yet. For this, we also need our robots to cooperate. And of course, the basis of a good cooperative play is passing.
Very fast, Alex, thank you.
Thank you.
Yes, of course, because if our robots are only able to shoot at the goal constantly, they'll probably not score a lot of goals, because we'll have some defenders of the other team trying to stop them, and there'll probably be other positions that are much better to try and score from. But getting the ball from one position to another can actually only be done by a pass. So really focus on improving these passing abilities. So how do we do this? Well, first we implemented the scoring approach that earlier Alex already talked about. So we score positions for how good they probably are to, for example, score from. So this way we can, for example, go for a risky pass to near the enemy goal so we can score the goal directly. Or, for example, we'll do a very slow build-up and do multiple passes and then try to score a goal. But when you try to pass, there are, of course, also other factors to take into account. Because a position may be really good to score from, but we should also have a robot that can actually receive the ball at that position. This means that a robot from our team should be able to go to a certain position within a certain time, because otherwise we will miss the ball and we'll still lose it and not score any goals. So that's why for all the positions that we've scored, we calculate if there is a robot from our team that can get to this position in the time it will need the ball to get there. But then, okay, we know we can arrive at a position, it's a good position to score from or to go to. Well, is there more to think of? Actually, yes, because we can also have an enemy robot from the other team actually intercept the ball, and then we'll still lose it. So we also have to think about the possibility of that happening, of another robot going into the way of our ball and then intercepting it, and we lose the ball also and not score any goals. So we take these three factors into account. Is it a good position to go to? Can a robot go there? And will our ball be intercepted? And if it doesn't get intercepted, well, then we say it's time to make the pass.
And now that our software has come up with all kinds of strategies, we of course need our robots to be able to accurately follow these commands and strategies that our software come up with. For this, our robots need the right tools to play soccer and the electronics to make it all come to life. This is what our hardware teams have been working on, both mechanics and electronics. Elisa and Tijmen will now tell you more about that.
Thank you, Tijmen and Alexander, for this nice overview of all the features you'll be adding to the software. However, as you already mentioned, we also need some robots to work with this AI. This is Elisa, she's from the mechanics team. I'm Tijmen from the electronics team. And we will give you some insight in all the changes we've been making to the hardware this year.
Yes. The hardware is of great importance for the performance of our robots and for executing the plays that Alexander and Tijmen just told you about. And we have to test our robots regularly to make sure that they behave properly during events and of course during a match. However, investigating the malfunctions and repairing the robots can be very time consuming. Therefore, to enhance the maintainability and the repairability of our robots, components and functions that belong together have been divided into separate modules. Each module contains all mechanical and electronic parts that are related to one functionality. And one of the advantages of this is that we can now quickly interchange a module to repair. And this can be very useful, for example, during a match. Because during a match, we might only have a couple of minutes to fix a broken robot. Secondly, we can now also test one single module. This means that we don't have to test the entire robot if we actually only want to test one specific feature of the robot. And we can now more easily identify the underlying cause of a problem.
And the very first of our 4 modules is our top module. It contains one printed circuit board, and on this printed circuit board you can find our microcontroller, motor drivers, communication chip, and IMU. The microcontroller is the brains of our robot, so it's very important that it keeps working all the time. We're using fuses and buffers to ensure that our microcontroller does not break down. The same goes for our communication chip. Imagine being unable to communicate with one of the robots on the field. It might get stuck on the middle of it. That would be unhandy.
Yes. The second module is what we call the front assembly. And the front assembly is the part of the robot where we receive the ball. And an important aspect of this front assembly is damping. Damping prevents the ball from bouncing off when it arrives at the robot. And of course we want to make sure that the ball stays with the robot and doesn't bounce off. Well, therefore, we designed this blue part that damps the impact of the ball. This new part has been made out of a thermoplastic material named TPU, which is a quite flexible material. And we can print these parts ourselves with our Ultimaker 3D printer, which has been provided to us by Card 3D Printing. And with this way of manufacturing these new parts, we can ensure that the damping behavior is consistent over all robots. One of the flaws in the old design was that the way of constructing it was very sensitive to inconsistencies. And because of that, different robots show different damping behavior. Well, with this new design, that issue is solved. Furthermore, since the trajectory of the ball isn't perfectly horizontal when it arrives at the robot, we designed the front assembly such that it is not only capable of handling the horizontal components of the ball impact force, but also the vertical components. This basically means that the entire front assembly can move diagonally. Finally, we can now also take out the front assembly and put a new one in way quicker than we used to. We can now do this in under a minute, while it took at least 15 minutes to do this with the old design.
Nice. So now we can receive the ball, but it would also be handy to keep the ball close to the robot. Therefore, we have this bar, which gives the ball a little bit of backspin, such that when the robot rotates, or when the ball kicks a little bit from the robot, it will roll back to the front of the robot. This bar is driven by a motor, for which we have designed a PCB, which contains some sophisticated circuitry. To this PCB, there's also an encoder connected. This encoder, we can use this encoder to monitor and adjust the speed of the dribbler bar. But you can also use it to gather information whether or not the robot actually has a ball.
Yeah, and if the robot has the ball, we of course want to be able to pass and shoot it, just like a real soccer player. So this third module is responsible for the kicking and the chipping of the ball. And we use solenoids to do this. A solenoid is a device that converts electrical energy into mechanical energy using an electromagnet that's made out of coil. And this electromagnet can generate a controlled magnetic field. This year we have been designing our own new solenoids that replace the off-the-shelf ones that we used previously. And these new solenoids are more compact compared to the old ones. And since we designed and manufactured them ourselves, we have better control over the characteristics of these solenoids and therefore also over, for example, the velocity with which we shoot the ball.
The circuitry connected to these solenoids has been revised completely this year. Driving solenoids requires a lot of power. Therefore, this module contains a very big capacitor, which you can see in the back. A lot of energy can be stored in this capacitor. However, handling this energy can be quite hard. For charging the capacitor, we use a transformer which can create up to 230 volts, such that the capacitor can be charged fully. If we want to shoot the ball, we can release all this energy instantly to one of the solenoids using the transformers, transistors, and MOSFETs provided by an experiment.
And then we have the final module.
The final module. This is the power module, which also includes our battery. The batteries you use can be quite dangerous if you handle them improperly. They can even catch fire. Therefore, this module, or the PCB in this module, contains some chips which prevent that. They can monitor the level of the battery, and if the battery is almost empty, the robot can send a message to our AI, so the robot can be substituted for a different one. There's also a circuitry on here which protects the rest of the robot. We can monitor all the power which is used in a robot, such that we can identify a failure before it actually happens. The last feature of this module is that it can interconnect all the other modules together. Therefore, we use these red connectors you can see, which are provided by the board. Instead of the 4 centimeters required for our previous PCB stack, we now only need 1 centimeter.
Yes. And in the end, these 4 modules together, the top assembly, the front assembly, the kicker chipper module, and the power module, form our new robot. And not only did we increase the maintainability and the repairability of the robots, we also formed a great basis for future generations of the robot team to implement even more new cool features in the robots and keep improving the robots just like we did this year. But we didn't just do technical developments, we also developed on a personal level. And Emil and Sarah will tell you more about that.
Thank you, Tuin and Elisa.
Hello, I am Emil Stuurman. I am 5th year member of RoboTeam Twente, currently finishing my master's in data science, and I'm right now a part-time member of the embedded systems sub-team.
My name is Sarah Omrest. I'm a full-time member this year, and I'm part of the artificial intelligence sub-team and the public relations sub-team. And Emil and I are going to tell you something about why we joined this team, what challenges we faced and what we learned this year, and also the fun and cool things that we do as RoboTeam. So take it away, Emil.
Thank you. 5 years ago, I was doing my master's in embedded systems, and I wasn't enjoying it. And I wanted to do something else, but I wasn't sure what. So then I learned of RoboTeam Twente from a computer science friend, and it seemed to tick all my boxes. It had electrical engineering and embedded systems, which I still enjoyed as a hobby. It had programming, which I love, and it had AI, which I was always interested in. Next to that, it had the management roles, which I was unfamiliar with. So I decided to quit my studies for a year, joined the AI team for the programming, and also joined the board as the role of external relations. And I chose that role because I wanted to get more in touch with the industry and see if there's anything out there that I really like and I would like to move my study towards.
I first heard about the RoboTeam about 3 years ago. A friend of mine was part of the team, and he always told me very enthusiastic stories about it. I was studying artificial intelligence at the time, and I've always had a great interest for robotics. So I knew that at some point I really wanted to join this team. I just didn't know when. Well, fast forward 3 years, and here I am. I joined the artificial intelligence team because I really wanted to put my studies into practice. And what better way to do this than actually working on a big AI? Next to that, photography and graphic design have always been a hobby for me, so the public relations teams always also sounded like a good fit. So for me, RoboTeam is really the combination between my studies and what I like to do for fun.
Each year, the new team or the old team makes place for the new team, with sometimes a few old team members hanging around. And so each year is roughly the same, meaning that each new team will also face the same challenges. And with our first years being 4 years apart, I think, we would like to share some of the challenges that we both faced in our first year.
Yes. One of our, well, both of us biggest challenge was working together with such a big team. Usually in a group project, you work with around 5 people, but in RoboTeam, you usually work with around 20 people. So that is a lot of different people that you have to work with. But it also means that you are dependent on all of these people. So one example from the beginning of our year is when we had to make team pictures. And I can tell you, it's a real puzzle to find about 2 hours where everyone, which was 25 people, could be there at the same time. So I was really afraid that not everyone would show up. I also had some nightmares about that. But at the end, I learned that if you communicate well, tell everyone what the plan is and what you expect from them, they will eventually show up. And I think we made some beautiful pictures. And one of our second biggest challenge was that during a student team, you don't really have a safety net. So working on a group project, it's very important that everyone does their task. But sometimes things go wrong. That always happens. But when you're doing a project for your studies, there's always a teacher or supervisor that can save your project. But when at RoboTeam a component doesn't arrive, that means that your robot can't be assembled, and that means that you can't test your robot. And that could be a real problem. So we learned from that it's really important that if something goes wrong, which is obviously bound to happen, that you really need to ask your fellow RoboTeam members for help. Because waiting by yourself hoping that something will get fixed might not always be the solution, and working together as a team, you might actually be able to solve very big problems that arise.
Well, Sarah and I joined the team for different reasons. We both had our personal goals, and that goes for every team member. And what I learned over the past 5 years, time and time again, is that it's important that you know why someone joined the team, and also that when you're doing the tasks that the RoboTeam require of you, that you're also able to fulfill these personal goals. And I've learned that the most in 2020, when Corona hit the Netherlands, and university closed down, and our office closed down, and worst of all, the RoboCup got cancelled, the thing that we're all working towards. And while we still had our tasks, we still needed to finish the robots for next year's team. The motivation, team spirit was just gone. People could not fulfill their roles again within the team. So we really needed to look and find a common goal to which we could all work towards, and that would still fulfill everyone's personal goals. That was quite a challenge. So we made a practice tournament against ourselves. Unfortunately, that lifted team spirits, and we were able to finish the robots. And with that lesson, I hope that if something like this ever happens again, we have the know-how to keep motivation and spirits high. And I'm also very happy this year that RoboCup will just continue as well.
I think we all are.
Yes.
Well, a year of RoboTeam is obviously not only about challenges and learning. We also do so many fun things throughout the year, and lots of those things weren't even possible if we hadn't joined RoboTeam in the first place. So one of these cool things that we do, we get invited to a lot of events. Some are by our partners. For example, in the first week of this year actually, we got invited by Saxion for the Meet and Eat. And that was the first time that as a team we had to organize an event. We had to stand there, we had to do a demonstration. And it was a real test to see if we could actually work together. It was so much fun because it turned out really great, it was great team building, and we got to meet a partner, which is always very fun. And then a few months later, we got invited by Deloitte to give a workshop to their AI experts. And that was also really scary because we are only a small student team. And we have to give a workshop to these AI professionals. And it was also really cool to actually share what we know with them. And over the years, we've also met some pretty cool people. A few years ago, we met with Hans Kraaij Jr. and with Jamie Heinemann in the past year. And it was actually really cool that we got to share our project with them and get their insights on what we do. And my PR heart beats a little faster every time we get invited to a show or make the news. So a few years ago, we got invited for Set Live, which is a national television program, and we got to actually show our robots, do a demonstration, and reach a wider audience than only the small audience that we normally reach. And this year we also almost made it into a Spanish TV show. But with all these fun challenges, with all these fun activities, which you can see behind me, which are way too many to talk about now, there's one big event that will happen still in March, and our team manager will tell you more about it.
Yes, thank you, Sarah. So, Now, here we are again. You've all seen our robot. You know what's going on inside there. You know what we've innovated on. And you've also gotten a glimpse of what it was like for us to be part of this team for the past 10 months. Hopefully, you've also, with my story in the back of your mind, through the technical talks, seen a bit of their excitement as well, even though it may have been technical at times. Now, the only thing that's left is what are we actually going to do with those robots? But before I get into that, I want to thank one more important part of our team, which is actually our partners. We're a student team. We're all very enthusiastic, but without the help of some of these companies, we really wouldn't be able to stand here today. So we have 4 of our main partners, Deloitte, Nexperia, Maxel, and the University of Twente. They help us tremendously, and they help us with a lot of different things, such as expertise, funding, but also just giving us new challenges that we can find, such as, for example, the stories that Sada told you about throughout the years. And we're happy to have them with us for all these years already. Next to these partners, we have many more megabyte partners who help us with sometimes very technical things such as components, or also funding or expertise, or any other thing you might be able to imagine. And they help us a lot with being able to build this project. And lastly, of course, we have many more partners in our kilobyte and byte packages who help us with various things. And we couldn't be able to be here without our partners. So that's why we want to always mention them specifically. But now, we have had all this help. We have had all this work with everyone working on this for so many months. Now is our time to actually shine with our robots. So in a little over a month, we will be in Bangkok with our robots. In the coming month, we will be making more of these robots, packing them all up in our suitcases, traveling them all across the world to Thailand, packing them out, putting them on the field, and competing against large teams from all over the world. In this World Championships, we could really use your enthusiasm as well. And although we're probably not going to see any of you there, although you're free to join if you happen to be in Bangkok. I don't know if you will. We'll see. But of course, to share this excitement with you, we'll be able to live stream it on our YouTube, and of course keep you updated on our social media. And we'd love to be able to show this to you, so make sure to follow us there. And then to wrap up, we have so much more to talk about. We have so many more team members, and they all love to share you all their stories of the past year and what we've done with these robots. So for that, we have a drink in the foyer, and you're all happy to stay here and chat with us. Thank you all very much for being here today. Thank you for your attention, and hopefully we'll see you soon.